Hello, class. As we're working here on number 5, we have a skydiver that has 70 grams. It's jumping out of the plane and beginning to fall. So we know it's accelerating downwards. But there's also at one point an air resistance of 100 newtons upward. So we're asked a couple things here. We got to find the acceleration of the jumper, but we also need to get this free body diagram and the sum of the forces. So I drew in the free body diagram where we have a larger gravitational force down, mg, than this air resistance up. And that's because the jumper is accelerating downward, so we know that there's going to be a larger force down than there is up. There's no forces acting in the x direction, so that's why the sum of the forces in the x direction still equals to ma, which equals to 0. It's just there's no forces acting on it, so there's no forces giving us 0 newtons. So then when we get to the sum of the forces in the y, we get the force up, that's the air resistance, and then we add in the gravitational force, which is down. So since it's down, it's going to be a negative mg, so air resistance minus mg, that equals to now ma in the y direction. Sum of the forces always equals to ma. Here we have the sum of these two forces giving us this ma. Now we are asked to find the acceleration of the jumper. Well, if we need to solve for this acceleration of the jumper, we're going to divide by the mass on both sides of this equation. So if we do that, we're going to get the acceleration in the y is going to be the force of the air resistance minus mg divided by the mass of the jumper. I'm going to fix that g so it looks nicer and neater. A little bit neater. So we know the air resistance. It's 100 newtons. And we're going to subtract the mass of the jumper, which is 70 kilograms. We're going to multiply by that 9.81. That's the g. 9.81 meters per second squared. And then we're going to divide by the total mass. The total mass of the jumper is 70 kilograms. So then when we take this to type into our calculator, we're going to get 100 minus 70 times 9.81. That's a negative 586.7, which is good. It's accelerating down. Now we're going to divide by the mass, divide by 70, giving us this negative 8.38. So a negative 8.38 meters per second squared, which is good. It's accelerating down. That's what we expect.